Anonymous asks, most people are bad at judging what is bad or good research. How does one become better at judging what is bad or good research? What are some of the most common things to look for? Practice doing it and share your practice. Write down your analysis of research and expose it to criticism and critical discussion. Write like blog post type documentation of your research about some paper and then post the link to FI and discuss it with people. Or if you're not ready for that yet, just start smaller and you can post like a link to a paper on FI with one comment about it. If you don't have comments, if you can't find things wrong with the papers, if you think maybe something's good, you can ask, does anyone have criticisms of this? You can find out what criticisms other people have. Another way to get started, besides practice, if you're not ready to practice, which is probably normal and fine, is look at examples, look at what other people have already done. So look through the archives and my blog and so on, my YouTube, etc., and find existing things where I investigated some sort of research. There's one where I investigate a brain scan related research paper by Sam Harris and some co-authors. For example, that's on my blog. There are many others. There's the Jordan Peterson serotonin stuff on my YouTube. If you look around, you can find like dozens, probably dozens of examples by me and a few other people where we have some criticism of some research. So you can look at what kind of criticisms did we make, what did we find wrong with it, and you can, take notes and then try to find some new papers, maybe find some similar papers, like papers in the same field doing similar kinds of work, and then try to apply the criticisms. Go through each of the criticisms that you read me using on some paper and try to figure out, does it apply to this paper or not? A lot of what you need to do for this stuff is just doing the work, checking things, reading all the details. If they make some claim and they have some citation, you can check the citation. Does the citation actually make the claim that they're claiming it does? Does it reach that conclusion? And if so, how does it reach that conclusion? Is it reasonable? So checking sources and then analyzing the source research, not just the research you're directly looking at, is important. It can take a while. But a lot of stuff, they hide a lot of their bullshit in some previous bullshit paper already concluded this, so I'm just going to cite it and then carry on. So a lot of times there's some like previous paper that's the main problem, and they're just using it so that they don't have to say the false bullshit themselves. They can blame it on someone else and just say, oh, I'm building on previous work, good for me. There's a lot of that. When you want to be suspicious is when they're saying like implausible things or things that seem really hard to reach as a conclusion. If you have a hard time thinking, how would they reach this conclusion that would be like valid and really convincing and robust and reliable and whatever? And if you have a hard time thinking of how they would do it, if it sounds complicated and tricky, then check the previous source and see how they did it. And just all you have to read to start is the abstract, and then the abstract will give you an idea of what was their method. It's like a summary. And then you might say, oh, okay, that makes sense. I didn't think of that. That's a good method. But you might say, hey, wait, that sounds kind of sketchy. That doesn't sound like a great method. Other things to look out for. The biggest overall problem in science today, I think, is explanationless science, where they're looking at correlations instead of causations, where they're associating things together, where they say X is associated with Y, X is correlated with Y. When we find a lot of X, we find a lot of Y, but they're not figuring out what is the causal mechanism. Anything that tries to associate stuff without a causal mechanism is pretty shit. Another major thing to look out for is, do you think that you could replicate this science experiment? So, do you think that they're giving you enough information that if you had the funding and you could hire some people and whatever, get a lab, would you be able to do the same experiment that they did? Or did they leave out so much of their step-by-step what they did that you just couldn't duplicate it? is most papers do not have enough information that you could really do the same experiment they did and be confident that it's actually the same experiment. And a lot of papers, there's also a problem, even if you could do the same experiment, would you be really confident you get the same result? If you're skeptical, if you think, there's like a 50% chance I just get a different result, then that's a bad paper. That's a real problem. There's a lot of stuff where they give enough detail for people to try to replicate it. Like maybe they should have given more detail, but people actually will try to do a replication. And then they just don't get the same result. So that happens a lot. So you want to watch out for that. Another thing you can check for, a general tip, is do they have a sources of error section? Do they have a part of the paper where they say, here are some limitations of our research, here are some ways we might be wrong? If they don't have that, that's a really bad sign. If they do have it, read it really carefully and think, are any of these limitations worse than they're really admitting to? Because sometimes there are these really, really huge limitations that just sort of ruin their research. Like, your research basically doesn't work and you know it because you just couldn't deal with this factor. And then what they do is they write it in the limitations section near the end, and they say, we might be wrong because of this. And then they just go ahead and reach their conclusion that they wanted to anyways. Even though, because of the limitation, you can't reach that conclusion. You just shouldn't be doing the research because the limitation is too big. So a lot of times, they actually know what's wrong with their work, and they'll even mention it to try to be like scrupulous and to protect their reputation as scholars and whatever. But then they just sort of ignore how big of a problem it is. They don't seriously analyze, like, what is the extent of the limitation? Does this really prevent me from doing the research or not? Like, why is it actually okay to go ahead with the research despite this limitation? Now, there's some limitations, and you're going to be like, well, that's pretty minor. The research seems fine. There's other ones where you're going to say, it's not obvious that the research is okay. Like, this might be a deal breaker kind of limitation. And they haven't given any arguments that it's not a deal breaker. So that's really bad. Even if it's not a deal breaker, that's really bad. Just because if it might be a deal breaker, they really ought to argue their case. And then you can analyze for yourself and try to figure out, is it a deal breaker for some reason? So sometimes the limitation is like, correlation is not causation. And then their conclusion is X causes Y. And you're like, wait, that was a deal breaker limitation. You know perfectly well you studied correlation. Now you're making a conclusion about causation. Those are not, you can't just say, oh, well, it's a limitation that it's not proof. Like, they'll phrase the limitation like, correlation is not 100% proof of causation. Not quite like that, but, something that means more like that. So they'll be like admitting that it's not 100% certain that their conclusion is true. But it's like, okay, but it's not at all certain your conclusion is true. Like, you're nowhere if all you have is correlation. That doesn't tell you causation at all. So that sometimes they'll pretend that this huge limit is like a minor limit. Another thing to watch out for is like fancy verbiage. Are they using a bunch of big fancy words and it's all confusing and hard to figure out what the fuck they're talking about? That's not always terrible. Some fields have fancy words in them that are like part of the field and genuinely useful. There's more. You'll see that sometimes in like chemistry is going to use some like tricky words that you might not know. When it's the social sciences, it is frequently illegitimate, and they're just making up a bunch of bullshit words to obscure how empty what they have to say is. Whereas in like chemistry and physics, the jargon is often like reasonable and useful shortcuts. But social sciences, it's often bullshit. So there's that. A paper should be pretty clear about what its point is, what it's saying. So if you have trouble understanding it, you can analyze in more detail, and there's probably something wrong there. Well, okay, if you're kind of a beginner, maybe you should analyze, and then if you still don't understand it, there's probably something wrong. Could be a sign there's something wrong. A common thing they do that's pretty bullshit is they say, like, we measured X using a test developed by previous people, here's a citation to their paper, and the test is just, like, total crap. It's like, we measured how happy people are using this survey, and we think our survey is objectively measuring happiness with high accuracy because these previous authors made it up and claimed it was great. You see a lot of shit like that. Anyway, practice. Actually read some papers, try to criticize them, try to find flaws. If you can't find flaws, ask other people if they can find flaws and try to learn from their examples.